Anybody get my question of the day?
Hold on. Cole. All right, let's see. Oh, where'd you go? Can you guys still see me?
Yeah, we can see you now.
Yeah.
Can you read that?
Yeah.
Cole, you're not even paying attention. I don't think he hears me. There he is. Cole, can you hear me?
Yeah, sorry, my parents were talking to me
Oh,
about
I was gonna
something.
say, I was like, I got a question on the board ready for you. So later,
I'm sorry. That's
I'll soak in water piping hot. My essence goes through my see-through clothes. Used up, am I? I've gone to pot. All right, anybody got an answer? Yeah.
Is it a tea bag?
It is a tea bag. It is a tea bag. All right. So, like I said, we did a lab on Friday. Most of us got pretty far on it. Did anybody? Yeah. Here's your paper. That's fine. That's fine. Do you guys need more time on that? A little bit more time? Maybe like 5 minutes? 7? 7.5? 7.5 minutes. All right. Take 7.5 minutes. If you guys need anything, I think you guys got all your trials done. You guys just got to do dimensional analysis, right? All right. Take a few minutes on that, and then we'll get into a little bit of notes, and then we're good to go. All right. So the actual speed was 6.4 seconds per 1 meter. 6.4 seconds per 1 meter. Okay. All right, so they're just doing some dimensional analysis. Do you guys have any questions about the lab?
6.4 meters per second.
6.4 seconds per 1 meter.
Oh, okay.
Okay. So they're going to complete that up real quick. Then we're going to take some notes. All right. I got to plug you back in. Sir. Perfect. All right. So let's see. Going to present now. Screen. Share. Sweet. Let's see what I can do. Slideshow. Set up slideshow. Okay. That there.
Yeah, exactly. It's first. No, Keegan's in 9.
Yeah, alright.
What do you need to ask me?
Yeah, what's up?
What is the length of the object?
Hold on, let me plug you in real quick. Can you say that one more time?
What is the length of the object?
I'm sorry. It's kind of, guys, can you quiet down just a hair? What'd you say?
What is the length of the object for the robot lab?
Oh, the length of the object?
Yeah.
I don't know, off the top of my head. About 13 centimeters front to back.
Thank you.
Yep.
You guys good? Yeah, what's up? 6.4 seconds per 1 meter. 6.4 is faster. Why was it faster? Why was mine faster? Just that was faster? Probably need batteries. Seconds per 1 meter. Yes.
Okay, so. I remember. The equations for
Equal participation.
Yeah, effective participation.
I mean, that would be. Schools are.
If it was input, then yeah.
Okay, yeah.
This is what I'm going to be doing. Yeah.
How are you guys doing?
Seriously, I was sorry.
This labs are. Everyone knows.
Okay, are you gonna go like
Easy on the first lap?
Yeah.
They usually go easy on the first lap, like
Fair enough.
continuously.
Gradually gets worse and
Yeah.
okay,
More
sounds
specific
good.
when you're 5 minutes.
Matthew out for some point of time.
I have no idea.
Yeah, he's got
I haven't heard anything.
But I can just rub it in with theirs.
I might not even do 6. Or you could just do it.
If you want me to, I would rather not. If he's out for 2 weeks, then yeah. I pretty much do it. But that's just. I don't think any of these actually even close to 6 miles.
Once you guys get done, find your seats, get out your guided notes. We're going to talk about some speed and velocity today. I will come around and collect your lab when you guys are done. Thanks, sir.
Can I wait five people at home?
They won't see you, but
You can walk up.
Can I walk out there and wait till he's presenting, so.
yeah.
Tommy, can you hear me?
Aiden, did you say
Tommy, I said hi.
That's okay.
But we'll have it.
Tommy, how long ago did you wake up?
like 2 hours ago.
He had to be up for
That's
couch.
not.
He had to go for couch, so.
Okay. He doesn't have it too easy. I mean, I kind of want to be up by now, so.
All right.
Yelling at somebody.
So like I said, if you guys could get out your guided notes, we're going to be talking about speed and velocity. If I can zoom in a little bit, that's kind of far out there, huh? All right, so little all right, so a little intro. All right, there's speed. Definition of speed, the equation of speed. Can make that a little bit larger, actually. You guys awake yet? There we go. Can you all see that all right? Speed is the ratio of distance and time. All right, it's always going to be positive because distance is always going to be positive. All right, however, velocity is displacement. All right, displacement, you can have a negative in there, right? However, negative represents, very good, direction, west, left, down. Okay, so there are the two definitions and equations. All right, it's super important to know that velocity is displacement. All right, that comes up and you'll see a decent amount of questions. Everybody close. All right. So what we're going to do, see if anybody runs track. Anybody run track in here? What do you run?
Like 100 and 200.
100 meter. That's what I'm talking about. This is going to be pretty easy. All right. So you run 100 meter. What's your best time?
Probably about
15?
Yeah.
15 flat. All right. 15 seconds. So in this example, we're going to calculate the speed from meters per second to miles per hour. Okay. So a little dimensional analysis. I'm just going to let you know, 1609 meters in 1 mile. 1609 meters in 1 mile. That's a conversion you will quickly remember. All right. Anybody know how many seconds are an hour? Very good. That's another one you'll quickly know. All right. To do a quick conversion. All right. 100 divided by 15 divided by 1609. 3600. Oh, it's a solid miles per hour. And I got, I'm going to 2 sig figs, 15 miles per hour. That's pretty good. 15 miles per hour, you could run beside a car. That's pretty good. Yeah.
Where are you driving at only 15 miles per hour?
Speed, school zone, maybe?
Well, that's usually 20.
Well, see, I grew up in Amish country, you know, and we just had a lot of buggies, which would go like 5 miles per hour. So you could run beside those, you know. All right, we're back to Cindy and Jim. All right, so we're just going to be doing a little conversions here. All right, Cindy sees an ice cream truck and charges towards it. Anybody run after an ice cream truck? No one's ever ran after an ice cream truck before? Yeah?
I didn't feel like getting up.
It's a great time. You just like, you know, you feel like, you know, like Forrest Gump running after him. All right. Sees an ice cream truck and charges towards it. She runs 60 meters in 8.2 seconds. What is her average velocity in miles per hour meters per second in miles per hour? And what is her average speed in meters per second in miles per hour? Okay. So I'm going to walk you through this first one, and I'll let you guys do the second one. All right. So in this first one, what is her average velocity? So velocity is displacement over time. Okay. Now, since she ran in a straight line, right, her displacement is the same as the distance, right? So her displacement is 60 meters per 8.2 seconds. 60 meters per 8.2 seconds. All right. And that will give you a velocity of 7.3 meters per second. Am I done? All right. Now, I can either leave it as it is since it's a positive number, or I could, according to the picture, what direction is she running? Right. So I could do right. All right. So I can leave it as it is, or I can add right to it. All right. Now, to convert that to miles per hour, all right, remember we got 1 mile over 1609 meters, and then 3,600 seconds in 1 hour. What is that going to be in miles per hour? So 7.3 times. I got 2 sig figs, 16. I got 16 miles per hour. She's a little bit faster than you. Just saying. She didn't run 100 meters. I mean,
Well, she's got motivation.
she does have motivation. I mean, I get it. Yes.
She's a lot faster than Jim. On the next question.
Oh, I was going to say, wow, you got ahead. All right. So now that's my velocity. What is my speed going to be in meters per second? Do I need to calculate anything? No, why not? It's already there. I ran in a straight line, so my speed My displacement and my distance are the same. So my speed and my velocity are the same. Once again, 7.3 meters per second, 16 miles per hour. Super easy. Oh, you guys can't really see that. I'm sorry. 7.3 meters per second, 16 miles per hour. Whoa. All right. Any questions on that? Move on. Sweet. Sweet. All right. Jim sees a spider. I hate spiders. Sees a spider and lets out a loud scream. Oh, she got a strawberry shortcake ice cream bar. That's a good choice. That's a good choice.
I think that's a neutral choice. I think that's not an ice cream connoisseur's choice.
Fair enough. Jim sees a spider and lets out a loud scream. Then he starts running away as fast as he can. He travels 20 meters in 10.2 seconds. What is his average velocity in meters per second, miles per hour? What is the speed in meters per second, miles per hour? Okay. Once you guys solve these real quick, get a little practice in. Okay. Remember, he's still going in a straight line. All right. But notice what direction he's running from the spider. All right, as some of you are getting close, what is his average velocity in meters per second? So you divide those two. I got 2.0 meters per second. Am I done? What do I have to add?
A negative or a left.
Negative or a left, right? Because he's running left. So I'm just going to add a negative. Answer's done. All right, and then I did that conversion. Answer done. Okay. Now, what is his average speed? He ran in a straight line, right? So it's going to be the same. However, speed involves distance, right? Not displacement. So our numbers are just going to be positive, right? So the speed is actually just 2.0 meters per second and 4.5 miles per hour. All right. It's just the positive because. Does that kind of make sense? All right, next we're going to kind of do a little loop-de-loop, all right? So Jim Jim and Harry are walking to the bus stop, which is a half mile to the left of Jim's house. It takes them 20 minutes to walk. That's a long time to arrive. As soon as they get to the bus stop, Jim realizes he forgot his lunch. Runs back in 10 minutes. Not too bad. And then rushes back and took another 12 minutes. What is the average velocity in meters per second? All right, we're not going to do conversion, just meter per second. What is the velocity? Okay. Remember, velocity is displacement over time. All right. So remember, you start with a half mile. Okay, you might still be trying to figure this out. Okay. But the velocity is displacement over time. So he started at one spot, went there, went back, and went there, right? So his total displacement was a half mile. And the total time it took him was 42 minutes, if you add up all those minutes. All right, so I have a half mile and 42 minutes. All right. Now, if you do your conversions, all right, I got negative 0.3 meters per second because it was to the left, right? Everybody got that? All right, and then Jim's average speed. So the total speed is distance over time. So the total distance, half mile, 1 mile, 1.5 miles in 42 minutes. Do your conversions, and I got 0.96 meters per second. How you guys feeling on this? Yeah.
The displacement's I kind of feel a little weird about it because, I mean, I understand he's going like only a half mile, but like, like the 42 minutes were like, I mean, you're going only a half mile away, you come back. It's like,
right,
like the furthest like displacement from where he is. That was
where he ended up. So like he ended up at the bus stop.
okay. So it's only going from like Jim's house to the bus stop. Like that's just far.
Right. Where displacement's just where he started. Doesn't matter what and where he finished.
Oh, okay.
That's it. That's a great question.
Okay.
Does that kind of help?
Mm-hmm.
All right. Doing all right? All right. Next example. All right. This is a loop. This is where it gets a little interesting. All right. Cindy is running a 5K, 5,000 meter loop for her first cross country. Any cross country runners? Sweet. Wow. A lot. Nice. Jim wants to make sure he's at the finish line to see when she finishes, but he also wants a hot dog. All right. Cindy usually runs 4.3 meters per second. How long does he have to get the hot dog? Okay. So let's solve this. What'd you do?
I divided 5,000 by 4.3 meters per second.
5,000 meters. And you divided that by
4.3.
4.3 meters per 1 second. Okay. What number you get?
1,162 seconds.
1,162 seconds. Beautiful. Do I have to convert that to minutes? Nah.
That's about 20 minutes.
Yeah. All right. So he has that long. 20 minutes to get a hot dog? That's pretty doable. You know, run to, I don't know, the B&B or something like that. All right. What is Cindy's average velocity? All right. What is her average velocity in this? Now, do not overthink this. Do not overthink this. This is tricky. She ran in a full loop. What was her displacement? 0. It was 0. So 0 over any amount of time is 0. Right? So her average velocity, 0 meters per second. Not very fast. Right? Does that kind of like, do you start to like envision what displacement, how like, it's a very large factor in calculating average velocity. All right. Oh, Cindy is happy to see Jim at the finish line cheering her on. However, she gets a little annoyed because he was eating a hot dog instead of getting water. How rude. All right. Concept. See how we're doing. A, B, C, or D. Anybody got a guess? Yeah. Is it D? It is D. Very good. Very good. All right. Constant speed moves every 10 meters every 10 seconds. Does that kind of make sense? Not too bad. Sweet. Let's move on. All right. Hopefully you guys are starting to get the hang of this. All right. As you guys know, I gave you guys homework on like Thursday, collecting it tomorrow. You probably saw a few of these examples on there. Now you're probably starting to get the hang of it. All right. Jim wanted to see how much Cindy liked him being at cross country meet. He decides to train so that he can join the team. All right. He sprints 100 meters in 13.2 seconds. Pretty quick. Pretty quick. Then he takes 50 seconds to walk back to the starting line. If his sprint direction is positive, what is the average sprint velocity? Okay. So basically you just do 100 meters. Where am I? 100 meters over 13.2 seconds. 100 divided by 13.2. I got about 7.6 meters per second. Okay. All right. And then the average walking velocity. So once again, he travels 100 meters, but this time it takes him 50 seconds. Okay. These are pretty straightforward, right? Oh, that's just going to be 2.0. Now, am I done? No, what do I have to add? Negative. Perfect. Thank you. Negative. All right. Since the sprint direction was positive, walking back is going to be negative. All right. And then calculate the average velocity for the entire trip. Don't overthink it. For the entire trip. What's his displacement? 0. Beautiful. Makes those questions easy, right? We can jump on those. All right, concept. Yeah.
Oh, does Jim change in mass very regularly?
Does he change in mass?
In example 9, he goes pretty fast. But then in example 10, it says that he's going as fast as he can at 5.3 meters.
Yeah, he had a quarantine for a long time, you know.
Some days you have more hot dogs than others.
Some days you have more hot dogs, right? All right, this is gonna be our last question. Last question of the day. Last question. I'll even zoom it up so you guys can read it. How many people say A? How many people say B? How many people say C? Okay. This is a tricky question. The big thing is that it says they both travel 4 miles. Now, if that was time, if they both traveled 4 hours, the answer would be B. But since it's distance, that is not your answer. The answer is C. Okay? The answer is C. Now, the reason why, let's say you travel for 4 miles and you're traveling 30 miles per 1 hour. And then over here, you're traveling 4 miles and you're traveling 50 miles per hour. Okay? If you do the calculation, you're going to be traveling at this speed for 0.13. Oh, that's terrible. 0.13 hours. And you're going to be traveling this side 0.08 hours. So clearly, you're actually going to be traveling at 30 miles per hour for a lot longer time. All right? So your average speed is less than 30 miles per hour. That's tricky. That's tricky looking at distance instead of time. All right. All right. Yes.
So instead of 4 miles, it was 4 hours, it would be the same.
They would be the same. Yes. Yeah. Great question. Great question. All right. So that's my one question. So hopefully you guys have enough to get the homework done. Most of you get most of it done, or all hopefully. All right. I am collecting the homework tomorrow. Tomorrow we are actually doing a speed. It's on the lab. If it's nice outside, we might go outside. All right. Go outside for lab number 2. All right. And then let's see how we're doing. Any questions so far? Speed, velocity. Starting to see the trend. Yes.
So even though the speeds, when it's 30 miles an hour for half the distance, and it was 50 miles an hour for the other half the distance. So when you're using you're averaging speed and distance, then and it's half and half. Would that be equal? And then if the times are you're on one speed for a longer time than the other, then would that one be the less than 40?
Let me see if I see what you're saying. So, what you got here? What you're saying is you're going slower. Guys, have a great Monday. Okay, you're going slower for longer. Slower speed for longer time. And then you're going shorter time for at a faster rate, right? So wouldn't that cancel out? Is that what your question is?
Well, I mean,
the biggest thing is the time. The time is the biggest part. All right. So since you're here for longer, your average speed during that time is going to be, it's going to be more effective than your average speed there.
It makes sense, because like, you add the two together, like the miles per hour at the top, like the speed, the average speed would be like less than.
Like 38 something.
Yeah. I'll give you an example.
I mean, if it was half to 30 and half to 50, so I don't understand why that wouldn't just be 40.
Right. I'll give you an example tomorrow.
Okay.
It took me a minute to like solve that one. But yeah.
I have a question.
Yes, sir.
So for the homework that is due tomorrow, have you posted it yet on Classroom or not? Because I don't see it.
I thought I did AP classwork.
Because I may just not see it. I don't know.
Wow, I got the lab. I did not. So I will not collect that for you guys. I'll give you guys a few days on that.
Okay. Okay, I appreciate it.
That will not be due. I thought I could have swore. I will do that right now, actually.
Okay, thank you.
So that was the, let's see. Yeah, no problem. Do you have any other questions about today?
No, I'm good. I'm good. I'll see you tomorrow.